Many Java applications have to communicate over the internet, making requests for content and processing the content after downloading it. I'll demonstrate one technique for doing this with core classes from the Java class library. I'm working in the Internet project, and there's already a constant declared named flowersFeed. This is a URL that points to a static XML file that's located on a remote server. I'll select that string and copy it to the clipboard. Then I'll go to Google Chrome, and I'll paste the string in and request the file. And I'll see that it's a simple XML file with a root element of products, child elements of product, and then more child elements within that. So now my job is to request that file and download it and display its contents for my application. I'll start in the main method, and I'll create an instance of a class named URL. Notice that there's more than one URL class. Be sure to choose the version from java.net. I'll name it URL, all lowercase, and I'll instantiate it using the constructor method, and I'll pass in my constant, flowersFeed. Notice that there's an error indicator, and that's because this constructor method can throw an exception. I'll leave that alone for now, and I'll fix the exceptions after I've done everything else. Next, I'm going to create an instance of a class named InputStream. This is a member of the package java.io. I'll name it stream, and I'll call url.openstream. Then I'll create an instance of something called buffered input stream, and I'll name that buff for buffered input stream, and I'll instantiate that with new, and then I'll call the constructor method for the class, and I'll pass in the stream. I'm almost ready to make my request, but before I do, I'll create a string builder object that will let me collect the data from the request. I'll name it SB and instantiate it with its standard constructor method. Now I'll execute a while loop. As I did once before, I'll set a condition of true, so I'll just keep on looping until I explicitly break out of the loop. Next, I'll declare an integer variable that I'll name data, and I'll get its value with buff.read. The read method goes and gets a single character from the stream. If it gets it successfully, it returns a numeric value. If it's unsuccessful, it returns -1. So next, I'll use an if statement, and I'll examine the value, and if it has a value of -1, then I'll break out of the loop. If the data value isn't -1, then I'll take that data value and interpret it as a single character with this code. First, I'll call sb.append, then I'll pass in the data value. But before I do, I'll recast the value as a char. So the data value will come back as a numeric, an integer initially, but I'll translate it to a character and then append it to the string builder. Once I break out of the loop, I will have successfully downloaded everything from the website. And so at that point, I'll output the results to the console, and I'll pass the string builder object to my println method. Now before I can run this code, I'll need to wrap all of it with a try-catch block. Notice that there are a number of places where I'm seeing error indicators, and that's because all of those spots could generate exceptions. So I'll select all of that code. Then I'll go to the menu and choose Code, Surround With. And I'll choose Try Catch Finally. We've seen try catch a number of times before, and it's effectively doing the same sort of thing as before. I'll run all of this code until I get to the end of the try block. But if at any point I get an I/O exception, the flow of the code will jump into print stack trace. Now, the reason I created a finally block was because I wanted a place to explicitly close my streams. The streams, just like in a previous example, implement the auto-closable interface. But this time, instead of using try with resources, I'm going to model my code so that I can close the streams explicitly. First, I need to make sure that both the input stream and the buffered input stream are visible to the current scope once I get into the finally block. So to fix that, I'll declare both objects before the try. I need to break up the declaration and the instantiation of both stream objects. IntelliJ IDEA makes it easy to do that. I'll click into that line and press Alt-Enter, and then choose Split into Declaration and Assignment. Then I'll take the declaration and I'll move it up above the try block. And then I'll initialize the value of the stream to null. I'll do the same thing for the buffered stream input. Now those variables will be visible when I get into the Finally block, and that's where I'll close them. I'll come down here and say stream.close, and then buff.close. Notice, once again, I see possible errors, and so now I'll press Alt-Enter again, and this time I'll just add an exception to the method signature, because it's conceivable that I could hit an exception when I call the close method, but I don't want to wrap all that in yet another try-catch block. By adding the throws clause to the method signature, it means I can run this code safely. I'll go to my problems view and make sure that I don't have any syntax errors, and then I'll run the code. And there's the result. I've successfully downloaded the XML content. From this point, you might parse the XML content using Document Object Model, JDOM, or one of the many other approaches that are available for parsing XML using Java. So that's a look at how to communicate over the web, making requests for content, and then downloading and getting content ready for processing.